Now let's do one more example where our picture is going to be a bit more complicated. We're going to look at something in terms of 3 sets. Our goal is going to be show that A union B intersect A union C returns the same region as A union quantity B intersect C. We saw an example of this earlier on. Now we're going to see if we can actually prove it. So we're going to follow the same sort of steps as before. We'll identify each of our regions and start sticking them together. So A is going to be the regions 1, 2, and 4. B, meanwhile, is 2, 3, 5, and 6. While C is going to end up being 4, 5, 6, and 7. So we start taking those pieces together. I'm not going to write it out because I don't have all the space I need. We can see that A union B would get us 1, 2, 4, 3, 5, and 6. So everything from 1 to 6. While A union C would get us 1, 2, 4, 5, 6, 7. Means that if we take both of those, put that symbol upside down, it's a little bit more reasonable to tell. If we take the intersection of the two of them instead, we'll end up with 1, because 1 is in both unions, that's divided in A both times. 2 is in both unions, it's in A both times. 4, again provided by A. Then we will also get from this 5 as it's both here and here, and 6 as it's both. So we will end up with the region defined by 1, 2, 4, 5, and 6. Be careful process, you got to be mindful and realistic. There should be a little bit more detailed with how I got those set. Got to be careful following through on that. Set algebra. On the other hand, if we look at B intersect C, we would get, not get 4, we would end up with 5 and 6 and not a whole lot else. These two sets don't share a whole lot, but if we take the union of A with the, we'll get everything in A back. We'll have 1, 2, 4, and we'll have these two which weren't in A. 5 and 6. So we will end up with, as before, 1, 2, 4, 5, and 6. Shows that these two set operations are equal generally.